Okay. Now, at this point, we have an x squared and a y squared term, which means it's not a parabola. We could also tell that if you look here, you'll notice that you've got an x squared plus y squared. That means you can probably tell it's going to be an ellipse or a circle, because the hyperbola has the minus sign between the two. Remember that? So right now, you know you're leaning towards either circle or ellipse. So the first thing you want to do is, what's that?
What is the whatever ended up being?
Well, when you complete the square, it should become positive. I don't know. I haven't gotten there yet. Again, when I set these things up, group them. X squared minus 6x blank plus y squared minus 8y blank equals negative 24. In order to complete the square in this set, I don't really have to do anything with the a value because they're already both equal to 1. So I take half of negative 6, I get negative 3, I square it, and I'm adding 9 to both sides. My term becomes x minus 3, 1 to be squared. I do the same thing with the y's. Half of negative 8 is negative 4. Square it, I'm going to add 16. So I get plus y minus 4 quantity squared equals 1. Well, here's the thing. You wind up equaling 1. So your a and your b are both the same, aren't they? It's 1. Everybody see that? How they both have 1 as an a and a b? This is a circle. This is a circle. It's a circle where the center is where?
3, 4.
Center at 3, 4? And what's the radius?
1.
1. So here's what's going to happen. When you have a circle and you have to label out the parts for it, label out one above, one below, one right, one left. What are those 4 ordered pairs? Yes, sir?
I don't get how you go from x squared minus 6x to x minus 3 squared.
Remember, this is when this part right here is the completing the square part. The rule was you take half of b, half of negative 6 is negative 3. I square it, I get 9. So you're asking yourself, what times what's positive 9 to add the negative 6? Well, it's x minus 3, x minus 3. What you're doing is you're creating that perfect square. But the trick was, whatever half of b is,
It goes down?
yeah, every time. It drops in there every time. Right? Yes, sir?
How do you find the radius?
Oh, just square it. It's r squared.
R. Oh, so
Equals r squared. Yeah.
So what if it didn't equal 1? Because we're 59,
Okay,
how do
then.
you know when you don't divide it by 56? Is it
What's-
equal for all
yeah.
1?
Yes. Yep. Ben's got a great question here, guys. On number 59, it's very similar, where you wind up equaling 36. But since you didn't have anything in the denominator, it could be 1 for both of them, then you just automatically understand that it goes that way.
So then if there was like a 2 in front of the x minus 3, then you would have to divide it by 36?
Yes.
And then total.
Yes.
I
Yep.
know what I've been doing wrong.
That's a good question, Bill. What was it?
When I took out, like, in 53, when I took out a 9 of the x's,
You didn't
I
multiply
got
it?
rid of it.
Oh, it's a common thing. Again, guys, what I was saying here is once you know where your center is, your h and k is at 3, 4, you have to label out the points that you plotted. 1 up, 1 below, so it's at 3, 5, 3, 3, and then 4, 4, and 2, 4.
And then that's just 1 over for each one.
Yes, sir. Yep. We're going to mark out your radius. I want us to get more specific with these because on Friday it's what I want you to do. I just didn't want to give you that much work going in on these problems because there's quite a bit as it is. Okay. Yes, sir.
So is H and K always going to be your center?
Always, always, always.
And your vertex?
Yes. All right. All right. Let's see here. 53. You've been to a museum with that before, right? Really? It's a, what happens here is if you, I think there's one in Rockford at the Children's Museum up there. There's
I
a,
have seen this.
the little, if you stand in front of this one and there's another one on the other side of the room, if you, the other person can hear you completely clear. It's really cool. Yes, sir.
I have one in my house.
Really? Me too.
Uh,
It's my basement.
so
You guys have a communicator?
it seems like the circle's awfully close to the ellipse.
Yes.
So anytime there'd be a larger number, like 16 is the radius for the circle, how would you know that's not going to just be divided out?
What happens, the dead giveaway for the, when you're looking at the equation for an ellipse versus a circle, the denominators for a circle, the a and b value, are the same. In an ellipse, you'll have an a squared of like 16 and a b squared of 9.
Oh,
See what I'm saying?
that-
The denominators will be different in an ellipse versus,
like they're going to have coefficients.
yeah.
Okay.
Well, the circle could have that too, but they could all drop out.
Yeah, gotcha.
All right, again, when I get to this point here, notice we've got an x squared and a y squared. You might also notice that there's a subtraction symbol between the two, which means it's probably going to wind up being a hyperbola. So I'm going to group them. 9x squared minus 72x minus y squared plus 8y equals negative 119. So in order to be able to complete the square for this, that first term has to be equal to 1, which means I'm going to immediately factor out the 9 with the x squareds. So I have x squared minus 8x blank minus 1, take out the negative 1, y squared minus 8y blank. Now on the other side then, I have to remember, I have negative 119. I took out a 9, so I have to put back in a 9 times something. I took out a negative 1, so I've got to put back in a negative 1 times something. All right? Usually most people will forget that 9 or that negative 1 to go on either side. You got to remember to put that on both sides. Okay? So now, again, go to your b value. What's half of negative 4? Or, it's half of negative 8.
Negative 4.
Negative 4. What's negative 4 squared?
16.
So we have 9x minus 4 quantity squared minus, again, it's the same thing. So fill in 16s here. I don't know what 9 times 16 is. It's true. It equals what? 9? Thank you. It equals 9. So what do you do now? Divide everything by 9. So now I have x minus 4 quantity squared. I'm going to put that over 1 minus y minus 4 quantity squared over 9 equals 1. So at this point, we're okay. We know it's going to be a hyperbola. With the hyperbola equation, the differences here is what comes first. In this case, the x squared term came first, so it's going to be moving left and right. So I know my center is at 4, 4, the h. Okay. I know that a squared is 1 and b squared is 9. What is my value of a? 1. B? 3. I'll write it as plus or minus 3 to remind myself. And then lastly, I got to figure out what c squared is. It's a hyperbola. So how do you find c squared?
You add a squared to c squared
Yep,
together.
it's the add them together. From here, we're going to walk through graphing this. And what are the ordered pairs you have to be able to list? We know the center is going to be at 4, 4. The A value, remember, that's center to vertex, left and right 1. So that means my vertex, excuse me, yeah, vertex is going to be at 3, 4, and 5, 4. The co-vertex, I go up and down 3 from the center. What is that? 4, 7, and 4, 1. Everybody okay with that? Focus. The focus, since this is moving left and right, I just have to add that C value to which coordinate, the X or the Y? Oh yeah, from the center. Which one am I going to add that to? Yes, very good. So here's what happens. I know that the square root of 10 is a little bit more than 3. I know it's going to wind up being, let's see, where we got 1, 2, 3-ish.
Can you say that on the test? Or can you just say 3 a little bit?
Yeah, because you're putting the dot there, but here's where the specific comes in. The ordered pair for the focus, I added the square root of 10 to the x coordinate. 4 plus root 10, comma 4. 4 minus root 10, comma 4. See what I did there? Yep. I just plus and minus the c value. I don't need to get the decimal equivalent. I'm plotting the close-ish, but I'm not writing down the decimal value of it. I'm just giving it in terms of the radical. Now I've got all of my ordered pairs. I know, oh, I didn't put in my asymptotes yet. Okay. Now, the equation for the asymptote in this, since it's moving left and right, is it A over B or B over A? B over A? I'm actually, is it B over A? I forgot
Yeah,
which one
it
it
is.
is. All right, I always forget which one is which. Okay, so now we know that this case it's going to be slope of 9, 3, plus or minus 3. All right, here's where it gets funky. I want you to write the equation of the lines of that slope. You have an ordered pair that goes through that line.
No.
4, 4.
Yes.
Yeah. Your center is always going to be a point that the asymptote goes through. So you use point slope form with that. I know I'll have two equations, one with a positive slope, one with a negative slope, which means you'll have two different y-intercepts. That make sense?
Oh, you don't have to do that with the test.
Yes, sir. What we're going to wind up doing today is hopefully you've gotten to the point where you've written out your equations correctly. This is the next step, is to graph everything and label parts. That's why I wanted to break it into these two chunks here. Yeah.
So the test will just be like graphing simple ones that we were doing at the beginning of the chapter, and then this.
Well, I haven't finished writing the test yet.
Fun, but is that what's gonna be?
Yeah, maybe. So here we have y minus 4 equals 3x minus 4. Here's one of the lines is y equals 3x minus 8. Then the other one we use the negative 3. Negative 3x plus 12 plus 4 to get 16.
What was the point for the equation?
What do you mean the points for
Like the equation, what it was?
for point slope?
Yeah.
Oh, the point slope form is that y minus y sub 1 is your slope, and your x minus x sub 1. This y sub 1 and x sub 1, that's your k and your h for your centers. Okay. That's what we're going to use. You'll use the center. All right. There's a lot going on some of these. I think you've showed me that one before.
Yeah, this is a new one. I got a Not yet.
So if you think about it, if this was a test question where I asked you to write the equation in the standard form, graph, and label all your parts, it's going to take you 3, 4, 5 minutes to do all that. How many of those could you really do?
One.
It's like one or two at most, you know?
Should be one.
Maybe 2,
No.
if you're feeling frisky.
You never know.
If you're feeling frisky.
It's, I get it, yes. It wasn't that bad. All right, let's go again. I'm looking at this one right off the bat. I might be able to notice that it's either going to be a circle or an ellipse. I don't know which one yet. Group your x's and your y's. So you're left like that. You have to start by taking the a value out. Factor out the a value, you have 4, the x squared minus 12x blank. Remember, I have to add in the 4 times something and something else. Be one time. I didn't have to factor anything out of the y's, so you don't have to worry about it.
It would be the 12 times something, right?
What do you mean 12?
Like, for the equals, you would have to add the 4 times something, or 12 times something, right?
There's no 12 times anything here. You're getting ahead of yourself. Half of negative 12?
36.
Add 36 to both sides then.
4.
Half of negative 4? Square it. Add it to both sides. And then I have to add all that together on the right-hand side. What do we get? 18?
I got 100. Yeah, but it's 4 times 36 is 144.
Yeah, it's all right.
Minus 48
Oh, okay. So now when you divide everything up by 100,
You would get like, you'd get x minus 6 squared over 25.
this is obviously going to be an ellipse.
I'm just gonna do this.
So we've got the ellipse now. Everybody agrees it's going to be an ellipse?
Yeah.
Which way is it being stretched, up and down or left and right? Well, let's look at your calculator. Notice that the larger values underneath the, yep, oops,
Oh, up and down.
It's gonna be up and down.
it's gonna be up and down, yeah. With the ellipse, your up and down is always your a squared. Or excuse me, not the up and down. Your larger term is always the a squared. I got braces on.
Thanks.
Was that last week?
Yeah.
I just
Yeah,
noticed.
it was last week.
I'm sorry. I'm sorry.
It's okay.
I'm sure, but I didn't notice it earlier. Yes, sir.
At some point, can I get that applications thing changed to my calculator?
Yes, sir. Oh, you have the,
Sync on it.
it doesn't, I don't think it's gonna sync into that calculator because of the, you have an Inspire starting point with the 84 plate. I have a blank one that for people that it doesn't work with, I just give you the blank one.
Then is that up and down?
Yeah.
I can use
So
my
H, I don't know which one. Yeah, H, there's very good H.
Oh, yeah.
All right, so again, at this point, we know that our center is at 6, 2 for your H and K. I know that my A squared is 100, B squared is 25.
So c squared would be the square root of 135.
Careful. This is an
C
ellipse.
squared, but c would be the.
Remember, hold on, slow down. An ellipse has a plus sign between the two fractions.
U minus 6. So it'd be
Subtract.
75.
Okay? You had that 5 root 3.
Is that a squared or top of left?
A squared minus B squared.
That one's for the hypotenuse.
Remember, guys, the easiest way to remember which one it's going to be is if you look at your equation. In the equation we have with the ellipse, there's a plus sign between the two, which means it's a minus sign with the a squared b squared. Yes, sir. All right. So when you go to plot it, we start at your center again. Our center is at 6, 2. Your A value is always the distance from center to vertex. Since it's being stretched up and down, what am I adding it to? The x or the y? I'm adding it to the y value. So I know that when I start listing my stuff out, we have a center was 6, 2. The vertex, well, that's going to be 6, 12, and then 6, negative 8. Plus and minus 10 from that. Are we okay with that?
Wait, which conic is this one?
The ellipse. Here's my vertices. The covertex is the b value, the distance from the center, subtracting the b value. So I'm going to move the x values around. So subtract 1, 2, 11, 2.
Wait, why is it that way?
You're going, remember how you go the other direction then? If it's stretched up and down, you're adding to the y values. If it's going left and right, you're adding to the x values.
So it's just opposite.
Yeah. So right now we have a rough sketch idea. I'm really bad with the potato. Yes?
How we plotted like sine and cosine graphs, or we always do a parent function first?
No, we don't do any parent function with this.
Could you?
No. There's really no reason to do a parent function with this because you can go right off of the equipment. The whole point is getting it to standard form because you can pluck out all the inputs. All right, there's no parent for this. And then lastly, when you go to your focus, remember, is going to be inside. I don't know where, it's going to be inside here. So what value am I adding and subtracting the focus value to?
5 root 3 plus or
Okay, but what am I adding it to, the x or the y coordinate in the center? The y. Again, so that puts my focus going to be at 6, and then, move this over just a bit, 2 plus 5 root 3, and then 6 to minus 5 root 3. And that is legitimate ordered pairs for funky roots, if you will. All right. I know that it's going to be more than 8, less than 9, root 75, bigger than 64, smaller than 81. I just move it around like that. Okay? I'm just kind of guessing-ish where they are on the graph, but I'm telling specifically where it is in terms of ordered pairs. Okay? Ellipses have a little bit less work than the hyperbola. Now, as far as the rest of the ones that are in here, what ones were you not able to complete the square with? I'll walk through some of that. I'm going to leave it up to you guys, to be able to plot and graph. Because for tonight, you're going to take everything you've done so far, plot and graph it, and list out ordered pairs. I've done an example of, I've done the example of the circle, the parabola, the ellipse, and the hyperbola so far. So I've done one of each. But now, if you have other questions as far as completing the square parts on these, let's do that now. Continue on that and make sure you're on the right track.
So we would have 44, 46.
The big book answers back there.
No, so we would have 46, 56,
Yeah,
54.
the paper one's got it's a worked out solution. I'm sorry, what was that?
We would have 54, 56, 57, and 59, right? Since we did 51.
You went through what, we go up to 60? Yeah, you guys get up to 60.
We did it up to 50.
Right, you did not have to do 58. 58 is
Yeah,
awful.
not 58, yeah.
Are there any others you want to double check, make sure you're all right on completing the square? While we have the time now.
Just get it now.
You got it now?
Yeah. I did it all wrong last time. So this is gonna suck.
Oh, jeez.
I got it all wrong too.
All right, well, time's yours. I'll let you guys keep walking through, and I'll just wander around and help you out.